After my last video, I did a few more tests using the formula editor in Prometric, and I then prepared 3 samples, okay, to just show candidates, okay, how they can use the formula editor in 3 approaches. Either approach 1, you can use the formula editor to type the formula, substitute the numbers in, and then calculate the output. Though I do not recommend this, okay? Approach 2 is to use a formula editor to substitute the numbers in directly. So that means you skip the step where you type in the formula. And approach 3 is not using the formula editor and just relying on whatever we have on the keyboard to answer. In my first example, this is tax on deferred capital gains. So let's say the investor invests $100,000 at 8% per annum for 20 years. The returns are in the form of deferred capital gains, which will be taxed at the end of 20 years when the investment is sold or realized. And the tax rate is flat at 30%. So we'll calculate the expected wealth at the end of 20 years. So for this, the future value will be based on the present value of $100,000. And then we'll multiply by 1 plus the pre-tax return of 8% to the power of 20 years. And then we multiply by 1 minus the capital gains tax rate, 30%. And then lastly, we add back the cost basis, which is 30%. And we'll get $356,267. Now let's see how we can do this in the formula editor in Prometric. To test out the formula editor, Google or go over to Prometric's website and search for the CFA programs page. Then click on tutorial. And then click OK to start and accept the terms and press continue. Then start the test. Alright, and you can find a text box, I think, in question 11. So you can make use of this box to test out the formula editor. So to calculate the expected wealth at the end of 20 years. So if I want to follow approach 1 where I will type out the entire formula. So I'll just type FV, future value, equals to present value. And then for multiply, of course, there are various ways to do it. You can type it as well. Okay, if you press backslash and times, okay, and press enter, there will be the multiply sign. Okay, you can of course use these shortcut keys here, like multiply here. Okay, and it will also, insert the multiply sign. Okay, so you can of course explore. There are different parts where you can find the multiply sign there, but I'll just prefer to type it. Okay. Of course, another shortcut key is you can press X 2 times, XX, that becomes multiply, right? So then we'll then continue with the formula. So we multiply by 1 plus the return, okay? And then to use power, to get power, you will press, a quick shortcut key is to press Shift 6, okay? Because the secondary button in 6, or the secondary function is the head, which is for power. So I'll press Shift 6 now. So immediately you'll see that there is a superscript. I'll type 20 for 20 years, or you can just type N, okay? And then I'll just press the right key to move down. Okay, then we have 1 minus T, the tax rate. So now I need a subscript for the capital gains. I want to type TCG. So I can just press Shift and dash. So that gives me the underscore key. So the moment I press Shift and dash is next to the 0 button on your keyboard. Then it will be a subscript, okay? And then I'll type CG, press the right key, and close the bracket. Now, of course, if you're not comfortable using the shortcut key, which I think you can get used to it, there is a button here under the second menu where you can actually click this for superscript, and this is for subscript, okay? But I'll prefer to just type Shift 6 for power and Shift dash for the underscore to push it to subscript, right? And then I'll just add in the cost basis, okay, T sub CG, okay? Press right and close the bracket. So there we have it, okay? You have the formula, which can be easily typed. I can copy and then paste this, okay? And then I can continue. I can substitute the numbers, okay? So it's 100,000, then it's 8% return. And then, okay, for the power, you just press right until it goes to superscript, type 20, and then press delete. Okay, so I find that it's easier because if you try to replace this immediately, okay, it will become, it won't be a superscript anymore. Okay, so I find that it's easier to actually just type the power and remove the symbol. And then the tax rate here will be 0.3, 30% plus 0.3. Okay, so that gives you a final answer of 356,267. So that's how you use the formula editor. The first approach, of course, is to type the formula, which I don't think is necessary. If you can substitute the numbers in directly and correctly, you wouldn't need the formula, okay, unless you're not sure of the inputs that you are substituting in, right? But if you get used to the formula editor, you wouldn't need to actually open the editor for any of these shortcut keys. Alright, of course, if you're not comfortable using the formula editor, you can just do it the old way. Just use your keyboard, okay? Just type FV equals to 100,000. Okay, multiply can just be shift 8, okay, for this asterisk sign, which is multiplication. You can use the different type of brackets, okay, like this is 1.08 to the power of 20, okay, and then you multiply by 1 minus 0.3, okay, plus 0.3 and close bracket, and then type in your answer, okay, then you're done. Okay, so that works as well, okay, if you just want to use the keyboard and not use the formula editor. For my second example, it's on the Singer-Terhaar model to compute the risk premium of asset classes. So we have the equity asset class here with the volatility at 18%. The correlation with global market portfolio is 0.75. The degree of integration is 68%. So the degree of segmentation will be 32%. And the segmented market Sharpe ratio will be 0.37. And we are given the risk-free rate of 2% and the global market Sharpe ratio is 0.3. So we'll use a Singer-Terhaar model to compute the expected return on this equity asset class. So we'll first start by calculating the risk premium for the equity market under perfect integration. So we'll take the correlation multiplied by the volatility of the asset class, multiplied by the Sharpe ratio of the global market portfolio, and that gives us 4.05%. And under complete segmentation, the correlation will be 1, okay, and then we'll multiply by the volatility of the equity asset class, multiply by the Sharpe ratio of the segmented market, and we'll get 6.66%. Then we'll take the degree of integration and compute the weighted average of both markets to get the risk premium for the equity asset class. So in this case, we'll take 68% times 4.05%, multiply plus 0.32 times 6.66%, so that gives us 4.8852%. So to get the expected return, we then have to add in the risk-free rate of 2%, so that gives us 6.8852%. So let's see how we can execute this in the formula editor. So we'll first start by entering or typing the formula for the risk premium under perfect integration. So I'll type RP for risk premium. Okay, then I'll press shift dash for underscore, and then type I, okay, for the asset class, and then for the superscript, I'll just put power, so shift 6 and type G. Okay, so that gives you the risk premium under perfect integration. So of course you have the raw, the correlation, which is raw. You can put backslash and RHO, so that's raw. Press enter. Okay, and then subscript I, comma GM for global market. Okay, then we have sigma. Okay, sigma is backslash SIGMA. Enter. Then underscore I. Okay, and then we'll put a bracket here, and then put slash for fraction. And then we have the risk premium of the GM. So I'll type RP underscore GM. Okay, and then we'll have sigma of enter and then GM. Okay, so that's I mean, if you want to type the formula, then I can just substitute the numbers in. So the correlation is 0.75, bracket 18% or 0.18. So if you want to type 18%, if you press shift 5, you can't actually display percentage, and here they don't really have a percentage sign. Okay, so if you really want to type the percentage, then what you can do is you can press backslash, then press shift 5 for percentage, press enter. Okay, though I think it's a bit of a hassle, you can just type 0.18, okay, 0.18 there, and then bracket, and the Sharpe ratio of the global market is 0.3. Okay, so that gives you 0.0405. Okay, and that's of course, if you want, you can type, you can of course write here 4.05%. Okay, you can write outside the box if you want to. Looks a bit ugly, but it works. Okay, if not, you can proceed with 0.0405. Then for the next part, I can copy the formula for the, let's see if it works. Okay, so apparently they removed the superscript and subscript, but we can easily just type back. So for the for under complete segmentation, that will be underscore I power of S. Okay, and then the correlation will be 1. Okay, we can substitute the numbers in. Then, so in this case, I'll just substitute the numbers here. So this is 1. It's still 18%, and the segmented market Sharpe ratio is 0.37. So I'll just change this to 7. So the risk premium will be 0.0666. Okay. Then you can take the weighted average using the degree of integration of 0.68. So in this case, the RP, the risk premium for the equity asset class, will be equals to 0.68 bracket 0.0405. Okay, plus 1 minus 0.68. Okay, then you multiply by 0.0666. Okay. You can type out the entire formula if you want to show the weighted average, but I think, of course, you can just immediately substitute the numbers in. So this is 0.048852. Okay. Then for the expected return, okay, you can just put E bracket R sub I. Okay. Oops. Okay, and that's equals to the risk-free rate 2% plus 0.02. Okay, plus 0.048852. So that would be 0.068852. Okay, or you can write in percentage form. Remember, you can just type 6.8852 backslash shift 5 enter. So that's 6.8852%. Right. So of course, if you don't go through the hassle of all this using the formula editor, then you can just type it in words. Like for example, under perfect integration. Okay, and then the next part is complete segmentation. Okay, then you have RP here, then you can immediately substitute the numbers in. I wouldn't want to type the whole formula like typing correlation. Okay, you can type raw if you want to, but I would rather just substitute the numbers in directly. So that would be like 0.75, 18% times 0.3, and you get 4.05%. Okay, if you want to make your point, you can put it in bold. Okay, so the examiner can clearly see there's a different section there. So for the risk premium for complete segmentation, that will be 1 times 18% times 0.37. So that's 6.66%. All right, then the risk premium based on the weighted, based on the degree of integration, that will be 0.68 times 4.05% plus 0.32 multiplied by 6.66%, which gives you 4.8852%. So the expected return would be 2% plus 4.8852%. So that's 6.8852%. All right, so that's your answer in this case. You just show the steps without using the formula editor. Okay, so it makes sense if you, as long as you substitute the numbers in correctly, then you will get, full marks for your marking. But bear in mind that if the final answer is correct, you will get full marks, even though you don't show your workings. Okay, the workings are only there to support and give you partial credit if your final answer is somehow incorrect. Okay, then having the working to back you up would be good. The third example is on closing the duration gap using US Treasury Note Futures contract. So we have the investment portfolio and the liability, and we have their market value and present value with the respective modified duration for each. And we have the basis point value of the cheapest to deliver bond and the conversion factor. So calculate the number of US Treasury Note Futures contract required to close the duration gap. So we will first start by calculating the BPV of the investment portfolio and the future liability. So the formula is to take the market value or the present value, multiply by the modified duration, and then we multiply by 0.0001, which is 1 basis point. An alternative is to divide by 10,000. For the investment portfolio, the BPV will be 38,000, and for the liability, the BPV will be about 35.6 thousand. Right, and then you will calculate the number of futures contract using this formula. We'll start by taking the liability BPV minus the asset BPV. Then we divide by the BPV of the cheapest to deliver bond multiplied by the conversion factor. So we'll get negative 30.897, which we will round to the nearest whole number. So that will be 31. So in this case, we will have to short 31 futures contract in order to close the duration gap. Now let's see how we can execute this in the formula editor. To start, we'll type the formula for BPV, okay, which is based on market value or based on present value, or you can type MV, okay, if you want to, okay, MV or PV, and then multiply times by the modified duration, and then you multiply by 0.0001. Okay, so for the BPV of asset, so the BPV underscore asset, okay, that will be equals to the market value 58,500,000, okay, and then multiply by the modified duration 6.51 multiplied by 0.001, so that would be $38,083.50. Okay, then you can copy and paste this. So the BPV for liability, that will be 61,200,000 times the modified duration 5.821, so that will be equals to 35,624.52. Right, then we calculate the number of futures contract required, so there's n underscore f, okay, equals to slash for fraction. Then we'll type the formula if you want to, BPV of the liability minus BPV minus the BPV of the asset, and then we divide by the BPV of the cheapest to deliver bond, and then we multiply by the conversion factor. Okay, so then you can substitute this in. I'll just copy this over and just substitute. So the BPV of the liability is, just copy this over. So we have 35,000 here. So I'll substitute the numbers in here. And then for the BPV of the asset, again, I'll just copy the number over. And for the BPV of the cheapest to deliver bond, based on the inputs given, this is 76.14, and the conversion factor is 0.9567. Okay, then finally, your final answer here is to take this, okay, copy the notation, right, underscore f here, so this is negative 30.897. If you want to use an approximation sign, you'll just press backslash approximation and then enter, and then equals to negative 31. Of course, you can find the approximation sign here as well, okay, in the shortcut bar, okay, so you can use that for approximation. So there you have it. Then of course, finally your conclusion is to short 31 futures contract. Okay, don't forget to conclude. This is the important part here. Right, of course, if you do not want to use a formula editor, of course, you can just calculate BPV of the asset, okay, and you can substitute the numbers in straight away. That's 58,500,000 multiplied by 6.51 multiplied by 0.001, okay, then you get the BPV, all right, and then BPV of liability, that's 61,200,000 times 5.821 times 0.0001, and that will be equals to 35,624.52. Okay, then your number of contracts required, NF, will be the BPV of liability. Okay, of course, if you want, you can copy and paste that number in. Okay, then we minus the BPV of the asset. Okay, and then we divide by the BPV of the cheapest to deliver bond, multiply by the conversion factor. Okay, and we'll get the same number, 30.897. Then you will round this to negative 31. Okay, and then you can arrive at the same conclusion. So you can, of course, you do not really need to type in the entire formula if, if you know how to substitute the numbers in correctly. Okay, then you can just type it in very few, just 3 lines, and you'll get the answer. Okay, but that's how you can do it with and without the formula editor. So of course, I find that of course candidates don't really have to worry so much about using the formula editor. There won't be any penalty for not typing the formula. Okay, as long as you can show your workings clearly, you can explain what you're doing, then you'll be able to get partial credits, okay, for your workings in the case where your final answer is incorrect. Right, so that's the end of the demonstration.